Hey there, ladies and gents, Mr. D here, and in this video we're going to start wrapping things up with regard to exponential and logarithmic functions and applications. So, without further ado, let's jump into it. Here we have a formula given to us. A equals 36.1 times e to the power of 0.0126 t models the population of California, A, in millions after t years. Now, t is going to be years since 2005. That means the year 2005 itself, t would equal 0. So part A is saying, what was the estimated population in 2005, aka the starting value? So when t was 0, what was our population? Well, we know that as being the y-intercept. Well, the y-intercept is just this a value out front. In this case, 36.1. And I do believe there's a little typo. This should be million, not billion. 36 billion people. Holy smokes, that'd be a lot. What percent is the population increasing per year? Well, percent, that means we're looking for a rate. What is the rate? Well, the rate comes from the exponent here, 0.0126. So the rate is 0.0126, but I want this written as a percentage increase. Well, that would be 1.26%. Remember, to convert from a decimal to a percent, you just shift over 2 decimal places. During what year will the population of California reach 40 million? So when it says during what year, that means we don't know our t value. However, they do tell us an a value of 40 million. So here's what we're going to do. We are going to plug in 40 for A, and that's going to equal 36.1 times e to the 0.0126t. And now to solve this, we are going to divide 40 to the other side. So we're going to have 40 divided by 36.1. So let me write that out. Sorry about the penmanship as always. So if we divide that out, we'll get 1.108, and I'm just rounding here, equals e to the power of 0.0126t. And as soon as you hit a point that you are stuck in exponential form, I can't really go any further. I've got that unknown value of t. Let me change this 6 a bit. Well, that's when I'm going to have to go from exponential form to logarithmic form. Since we're dealing with a base of e, I need to use a natural logarithm. So the natural logarithm of 1.108 equals 0.0126t. And now this just goes straight into my calculator. When we get the t value, it's going to give us something, or it should give us something, in the neighborhood of 8. Well, we have to keep in mind, t represents the years after 2005. So if it's been 8 years after, we'd get the year 2013. All right. Number 2. When the outside air temp is anywhere from 72 Fahrenheit and 96 Fahrenheit, the temperature in an enclosed vehicle climbs by 43 degrees in the first hour. The function is given to us. Hey, that's neat. And that models the temperature increase after X minutes. So what we want to do is part A, use the function to find the temperature increase to the nearest degree after 50 minutes. Okay, so they're giving us an X value for part A. Well, that one should be pretty straightforward. If I plugged in 50 for X right there, I can go straight to my calculator, right? 13.4 times the natural log of 50, close out the parentheses, minus 11.6. So that one's not too terrible. Ugh. Wrong box. Act surprised when that one gets uncovered. So the increase is going to be 41. Part B says how long, so we're solving for X, until the temperature increase is 50. Okay, so this is giving us an f of x value now. So if I were to plug in 50 for f of x, I'd get the following equation. Well, to solve this, I need to add 11.6 to the other side. So we'd get 61.6 equals 13.4 times the natural log of x. I'm slowly going to work away to get the x by itself, so I need to divide out the 13.4. So if I do 61.6 divided out 13.4, we'd get 4.597 after some rounding equals the natural log of x. Now at this point, I'm trapped. I'm trapped in logarithmic form. I can't really do anything else. So anytime dealing with exponentials or logarithms, if you're trapped in one form, you translate it to the other. So I want to put this in exponential form. The base of a natural logarithm is e, so I could say e to the power of 4.597 equals x. And now I get to use my calculator. When we punch things in, we should get roughly 99. Roughly 99. All right. Number 3, the percentage of adult height, f of x, attained by a girl who is x years old can be modeled by 62 plus 35 times the log of the quantity x minus 4. X represents the girl's age, assuming they're between the ages of 5 to 15. Because after that, the growth rate is obviously going to stop. Prior to that, kids, from infancy to toddlerhood, the growth rate is significantly different. Part A, approximately what percentage of her adult height has a girl attained by age 9? Well, this is just a plug and chug. Right, we'll plug in 9 for x there, straight to our calculator. Should get 86%. Part B, approximately when will she reach 90% of her adult height? Well, we'd plug in 90 for f of x. So 90 equals 62 plus 35 times log x minus 4. So now this is going to be just like the previous examples we've seen, right? We're going to be moving things around, so we would subtract the 62 to the other side. We would divide out the 35. So we'd subtract 62, we'd divide out the 35. And then we'd have to write this thing in exponential form because we're going to be stuck in log form. So we would have to do 10 as our base because it's a common logarithm. So we would subtract 62, and then we would divide out 35. We're going to get some decimal for that. From here, ooh, that's a gross 4, I'm sorry. From here, we're going to work through and solve it. Everything on the left side is going to be a decimal of sorts. We would then do 10 to the power of whatever this turns into, and that's going to be set equal to x minus 4. So 10 to this power equals x minus 4. Add 4 to the other side. If done correctly, we should have around age 10. Roughly age 10. All right, this next little bit, we will have hard copies of these available in class, and you also have access to this online. It's been posted to Classroom. But if you want to pause the video to see what some of the answers are, obviously this is not my handwriting. Shout out to Miss These2. But if you want or need to see the solutions to the review sheet that we'll be working through in class, here you go. All right, folks, that's going to conclude it for this video, but you know the drill. If at any point you have any questions, please do not hesitate to ask. And as always, good luck, have fun, be safe, Rolls Tide.